8, 7, 6, 5, 4, 3, 2, 1. All right, here we go. Levi, what is the exact value of the sine of 240 degrees?
The value of 240 degrees is 2.
Come on, Levi, you're supposed to have this by now. That's why I put it on the board 10 minutes ago. Akil, what's the exact value of the sine of 240 degrees?
Negative 3 squared over 2.
Say it louder.
Negative 3 squared over 2.
Negative 3 squared?
Negative 3 squared root over 2.
Agreed? Yeah, that's the exact value of sine of 240 degrees. Rosny, what's the exact value of the cosine of 330 degrees? Good. Square root of 3 over 2. Maya, what is the exact value of tangent of 135 degrees? Cool. All right, we okay with that?
Yeah.
Made sense to everybody? All right, yeah, we're just looking at our unit circles. That's all we got to do for these special angles. The rest of them, just like we did yesterday when I gave you 20 degrees and said estimate, the rest of them, you could just estimate. You could figure out where that point was, and then you could look at it and say, well, that looks like about. Based on the numbers that you already know, you can just estimate the rest of them for anywhere on the circle. Assuming you don't have access to a calculator. But the nice thing is you don't even have access, you don't even need to have access to your unit circle. Because you can build that unit circle really, really easily. As long as you know the 30, 60, 90 and the 45, 45, 90. You could walk up anywhere and just say, well, there's 30, there's 45, there's 60. And what do I know? Well, I know that 1/2 is one of the numbers and root 3 over 2 is the other number. So this has to be root 3 over 2 comma 1/2 because the x is longer than the y. And you do the same thing at 45 and you'd say, oh, I know they're both the same. And it's the middle number. And then you'd go to 60 and you'd say, oh, it's just the 30 switched around. So it's 1/2 root 3 over 2. And if you wanted to think about that, you'd say, oh yeah, short and long. Boom. You know cosine and sine of every one of those angles. And as soon as you know that, you know this one, you know that one, you know that one, and so on, and so on. All right. Okay. Any questions before I move on?
Wait, I actually do have a question.
Yeah, go.
What do you, like, if we put like 0.8, negative 0.7, 0.87, would that be wrong?
Well, it depends on the question. What is the question?
What is the exact value?
Is 0.87 an exact value?
I'm pretty sure, wasn't it?
Really?
Well, no.
So square root of 3 over 2 is exactly 0.87?
No.
No, it's right.
No.
No,
It's right.
I will say, with all honesty, that I'm actually getting a little tired of wiping down this board.
I'll do it for you. That's every single time you need it.
Every single time.
So, there's a reason yesterday that I took a few minutes to talk about unit conversions. One was because the bird poop problem is fun. I enjoy the bird poop problem, as do my students. But two is because today what we're going to talk about is we are going to talk about another way to measure angles. So let's start with, what do we know about measuring angles? How many angles how many degrees in a circle?
360.
Why?
Because it never ends.
It's because that's what it was.
Why 360? Why? Why would we choose an idiotic number like 360?
That's like we did the alphabet.
It's not idiotic.
Actually, it is a
By a lot.
it is a very nice number, and here's why it's a nice number. What are the factors? What numbers go into 360? 2, 4, 6, 5, 6, 8. Yeah. 9, 7 doesn't. 10, 12, 15.
You're not wrong.
Anything before?
1.
Yeah, 1 goes into everything. I don't care. 18.
4.
This is actually a pretty cool number because it is divisible by so many things that you can split it up a lot of different ways. The Babylonians used a base 60 numbering system. There were 60 different characters representing the numbers 1 through 60. And when you got to 60, you had a character for 60, and then you started adding 1, 2, 3, 4, all the way to 60 again, and now you're to 120. But instead of only 10, like we have, they had 60. Can you imagine what kindergarten, first grade looked like back then? 60 different characters for different numbers. And I don't know exactly, I don't know if anybody knows for sure why they chose to split this into 6 pieces. Could well have just been because it worked. So you've got 6 sets of 60 makes up a full circle. But you know what? It works fine. So what the heck? Why not? Who cares? You know, we could do 100 degrees, go to a decimal system. That's what I do whenever anybody from Canada or Europe. By the way, people from Canada and Europe are really annoying. They really are, because they think they're so darn superior with their stupid metric system. Well, we use the metric system. Whatever. Who cares? Who cares? Yeah, and they're not even consistent about that. They don't always use a metric system. They just sometimes use a metric system. It's totally a matter of convenience. But, you know, okay. But when they say, we're superior, we use a metric system, I say, yeah, what about circles? Well, what do you mean, what about circles? You got 360 degrees in a circle, or do you have 100 degrees in a circle? Then don't talk to me. Go fix your own country and then come back and tell me about your stupid metric system. And then they usually look confused and go away, which was really my goal the whole time. And I can make fun of Canadians because I grew up in Canada, so I'm allowed to.
What about Europeans?
What about Europeans? Yeah, I grew up in Europe too.
Basically.
And the Middle East. Yeah, I've lived in 4 different countries, so in 3 different continents. But what we're going to do today is we're going to talk about another way to measure angles. Instead of 360 degrees in a circle, we're going to look at another system. And we're going to start by pointing out that that is 1 radius. Just like on our unit circle. We're going to define that length as 1. Doesn't matter how big or small your circle is, that's 1 unit. Okay. Now what I'm going to do is I'm going to take some wool, and you guys can work on your homework because I'm going to knit a scarf. No, I'm just kidding. I'm going to take some wool because it's convenient for measuring things. And I'm going to measure off exactly 1 radius worth of wool. That piece right there is exactly 1 radius for my circle. And then what I'm going to do is I'm gonna measure around the edge of this to right there. And that length is exactly 1 radius also. It's curved, but it's exactly 1 radius. Is everybody comfortable that the length of this line and the length of that arc are the same? Okay. So if I go to here and I draw a radius back down to the center, there's an angle here. Agreed? Theta, that angle is equal to 1 radian. Mr. Ermening, I don't get it. Why 1 radian? Because that's a definition. 1 radian is defined as the angle created, and I'll move out of the way. Try to move out of the way for everybody. The angle created when you move 1 radius around the edge of a circle. The angle created when you move 1 radius around the edge of a circle. So let's compare that to what we had over here. What is 1 degree? It's the angle created when you move 1/360th of the way around the circle, agreed? If you take the circumference of the circle, divide it by 360, and go that far, you've just swept out 1 degree. If I take the radius of the circle and go that far around the circle, I've just swept out 1 radian. Now, let's talk about the circumference of a circle. What is the circumference of this circle? Levi.
I2R.
2 times pi times r. Do we know r for this circle?
Yeah, it's 1 unit.
Oh, it's 1. So the circumference of this circle is equal to 2 pi. What are my units? Not radians, because it's a circumference, it's a length. Radiuses.
Radiuses.
2 pi radiuses. You guys know the actual plural of radius?
Isn't it
Radii?
radii?
Radii. But I like saying radiuses because it's fun to say. Radiuses.
Radius. Radiuses.
So does that mean that if I went from here to here, and then I did it again, 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 shouldn't I have 2 pi of those all the way around the circle?
Theoretically, yes.
So if I were to measure this off, there was 1 of these. And then there's,
You know, I'm probably gonna reach. Never mind.
I felt that one.
another one of them. So there's 2 radiuses, starting at the beginning here. And then there's, oops, actually let go. Let's see. Just sort of a pain. 3 radiuses. And then, now it'll get easier because I'm going down. There's 4 radiuses. And I let go again by accident. There's 5 radiuses. And there's 6 radiuses. And we're looking for 2 pi, which is approximately, oh no, but I've got a 2.
Oh, like 4.5.
Really? 3.14 times 2 is like
I thought
4.5?
I thought we were gonna round because 3.1415.
You're gonna round 6.28 to 4.5?
Oh, maybe. They're closer both.
0.28, about a third of another radius. So obviously I haven't been super accurate here, but there is about 0.28 radiuses. Agreed? Because the whole thing has to be, from here all the way around the edge, has to be 2 pi radiuses, or about 6.28 radiuses. So how many of these angles do I have in the full circle? 6 and an extra little bit. But how many do I have exactly? Each radius is 1 radian. Each radius is 1 radian. 2 pi radii in the circle. Therefore, 2 pi radians in 1 circle. So here's my question, and you'll need a calculator. Approximately how many degrees in 1 radian? Go. Discuss with your partner.
Wow.
Are you ready to explain how you got it?
Yeah.
The whole radius. I thought I had it on there, but I don't.
Okay. So if I can find
If 1 radian is 2 pi, then that means you just have to do 2 pi. Each radius is 1 radian, 2 pi radius is a circle, therefore 2 pi radius is 1 circle. So therefore each radius is 1 radian, right?
what?
Yeah, each radius is 1 radian.
Yeah.
And if the whole radius is 2 pi,
Yeah.
and there's 6.28, you divide 6.28 by 6.28.
To get 1.
Yeah, that's 1 radius.
Well, I don't think so.
I think it is.
I don't think that's right.
I think you're just overthinking it.
No.
How many degrees approximately is 1 radian?
Yeah. What were you on?
Not on degrees. Okay.
Okay, I don't know, but because you're gonna be too
Not
but
just.
you do too high.
So, well, technically it just be tangent 1 over
If you
1.
like,
So.
no, it's not tangent because that's gonna.
All right, let's see what we got here. Everybody looking up front? Leroy, do you and Nate come up with something?
Yeah,
What'd you come up with?
we believe it's 60. Well, we talked about it for a little bit, and then I tried some in the calculator. I tried 360 divided by 2pi, which didn't really seem right, because it was 500 something. So that.
Wait, 360 divided by 2 pi is 500 and something? Let me ask you a quick question before we get back to Leroy's answer. We're going to come back, Leroy. I got a couple questions for you. Did you type 360 divided by 2 pi into your calculator?
Yes.
What did he actually tell his calculator to do, Macia? See the problem?
Yep.
The calculator, when it comes to division and multiplication, will just move left to right.
Okay, this makes more sense.
Yeah. Leroy, how do you get 60 degrees?
Because, wait, we're trying to find the theta, right?
Yeah, we want to know, that's 1 radian. We want to know what it is in degrees approximately.
Because each side is 1 radius,
Okay?
then it would be safe to assume each angle is equal. That would not be correct.
Well, here's the problem that I maybe have with that statement. Is that equal to 1 radius?
No.
You're right to the extent that you wanted to say, let's approximate this as an equilateral triangle. But in fact, because of the curve, the side of that triangle is a little bit less. So 60 is close. Hang on just a second, Cameron. Here's the problem with 60. If I've got 6.28 of these things in a circle, and I multiply by 60, I'm going to get more than 360 degrees, aren't I? If I had exactly 6 of them, then I don't have a problem. But I've got a little more than 6. So 60 is close. Cameron, what were you going to either suggest or ask?
I was going to say, I believe it's 57.3.
How did you get 57.3?
Well, the circumference of the circle is 6.28 radians, or radiuses. So I divided 360 degrees by 6.28.
Hey, Nate, isn't that what you were trying to do?
Yeah.
Except with 2 pi, right?
Yep.
More or less decimal places there. But yeah. Take the degrees in a circle, divide it by the radians in a circle, and that will tell you how many degrees per radian. Guys, let's think about this with our bridge method. I've got 1 radian, and I wish to convert 2 degrees. My conversion factor, 360 degrees per 2 radians. Where does the radians need to go in my bridge? Bottom right. 2 pi radians, 360 degrees. 1 times 360 divided by 2 pi. There's your conversion. So, let me ask you this. 170 degrees. How many radians? Go. When you write this into your notebook, I want you to put it in a bridge, then type it into your calculator. Or type it in your calculator and then write it into a bridge. Because I'm going to ask you to do something tricky with that in just a second. Uh-oh. For people watching at home. Boom. Now they can see the other board. Cameron, what goes into my bridge? What? What do you mean you have no idea? What are you trying to get rid of, unit-wise? So where does degrees go in my bridge? Good. How many degrees am I dealing with here?
Well, you're dealing with, 57.
Nah, don't go approximate, go exact.
Okay, so 2 pi.
2 pi degrees?
No. 2 pi degrees.
You said degrees go bottom right. I said how many? And you said 2 pi. So I'm confused.
I'm confused too.
So start over again. You said degrees need to go down here. What's my conversion factor?
57.
No. Written all over the board. What's my conversion factor? We just did a problem.
360. No. Yes. Oh my goodness.
Oh my goodness.
How many radians is that?
That is
Do not say 57.
6.28.
No, exactly, not approximate. 2 pi radians. Where does that go in my bridge, Cameron?
Right.
Aha! Boom. Guys, this is the whole point of the bridge method. It's impossible to get it wrong.
I got it wrong.
Once you get used to the bridge method, it's impossible to get it wrong. Cameron's still getting there, and that's okay. I don't expect you to learn everything the first time I throw it up on the board. You'll get there. Degrees cancels out. How do I convert this? Nate.
You multiply 170 by 2 pi, and then divide that by 60. But not 60, 360.
170 times 2 times pi divided by 360. What do we get?
Almost 100.
Yeah,
Right.
2.97.
Ryan, is that exact or approximate? Do we agree that that's an approximate answer because we had to round it off at 9.7? I would like you to discuss with your partner how we could get an exact answer for the number of radians in 170 degrees. Discuss.
You would have to leave, no, you have to leave pi instead of
It's just a double.
yes,
Yeah.
yes.
You would have to,
You would have to
you
leave
leave
pi.
170 times 2 pi, but you leave the pi.
But you leave the pi. You say no to that pi.
You divide by
I think
260.
you leave the pi.
Oh yeah, you have to leave the pi because the pi is 3.14159567.
Hey, look at you go.
Yeah,
What up?
examples are wrong.
I learned it, so still pretty impressive.
Did you not have Mr. Bryan?
Nope, I had degree, so I was in advance.
We have tie day.
Yeah, you suck. Didn't get that.
Carson. Yeah. Yeah, come up with an idea.
We came up with an idea. I don't know if it's in the most simplest form, but.
So before Carson continues, let me throw out just some life advice. Don't start every explanation of any answer to any question with a long-winded explanation of why it's probably not right.
No, that's right.
Because when you do that, you're predisposing your listeners to go, oh, well, then why am I even listening? Start by presenting your explanation and then say, does anyone have any questions? And then maybe somebody will point out something that you missed or you overlooked. But don't start by telling them how you're wrong. It's just a bad idea. Carson, what did you guys do?
We said 170 times 2 pi.
Well, that's what I got here.
Yeah, over 360.
Oh, okay. I'll keep going. But you didn't do anything.
Yeah, I don't know how to do it from there.
Personally, I was thinking.
That is an exact answer, though, isn't it?
No, it is not.
It is. It is. It's not particularly simplified. Nate.
You could do 340 pi over 360.
Oh, interesting. That is definitely simpler. Of course, it completely ignores every discussion we had over the course of many weeks about the best way to multiply fractions, which isn't to multiply and then simplify. It's to what? Simplify, then multiply. Why not make your life easier? But I don't disagree. I mean, it works. Now what? Still not simple. Ryan.
You can divide by 20 on the top and bottom.
Oh yeah, this is divisible by 20, and that's divisible by 20. And now I got to do 34 divided by 2 and 36 divided by 2. That's so annoying. Why would you make me do that?
17.
Because that's an exact answer. 2.97, yeah, about. 17 pi over 18, exact. So here's the deal. Radians, we usually want to go exact. Degrees, we usually go approximate. The reason we go exact on radians will become more clear later on. There are some calculations that we do with angles in radians, a lot of calculations that we do with angles in radians, where it's useful to just leave the pi there, because when we start doing the calculations, pi's cancel out and then we don't have to deal with them. And we haven't rounded our first number to 2.97 and then have to round it again when we start to do the other calculations, making it less and less accurate. So strategy number exact, right here. If I ask you to turn degrees into radians, generally that's what you're going to be doing. You're going to turn it into something that includes the number pi. All right, are we good with that? So let's do some practicings.
Wipe down the whole board.
What? And now I have to wipe down the whole board
I
again.
I can do it for you.
No, I'm good.
Oh, yeah.
Love
Convert.
it.
1. 290 degrees to radians. And 5 pi over 12 radians, 2 degrees. I want you to use a bridge. I want the radians exact. The degrees can be approximate if necessary. Ryan, number one.
So you've got 290 degrees in the top left, and in the top right, you've got 2 pi radians, and the bottom right, you got 360 degrees. And I guess probably better to like divide them first. So you can cancel out a 10 in the 360 and 290, and a 2 in the 2 pi, which is 36. And then multiply.
Because there's a reason I like simplifying first. It's just a lot easier to look at what goes into numbers when they're smaller numbers. And the bigger your numbers get, the harder it is to know, well, what goes into that number and how many times. And now I'm having to do all sorts of calculations. And every time you force yourself to do a new calculation, there's a chance you make a mistake. The more calculations you do, the more chances there are to make mistakes. And the bigger they are, the more likely they are. So I like that, the idea that just they're both divisible by 10, and then you get 2 over 36, which goes down to 18, and then you know, wait, look, 29 and 18, they've got no common factors. I'm done. Here's the other nice thing about these exact values. If I said where on a circle is 2.97 radians, the answer is, I don't know. But where's 17 over 18 on a circle? It's just less than halfway around, right? If 1 pi is half the circle, if this is pi, half a circle, and that's 2 pi a full circle, 17 over 18 is just a little bit less than 1. So 17 over 18, 17 pi over 18 has got to be up here somewhere. Where's 29 over 18? Well, it's definitely not all the way around, because that would have to be 36 over 18. So 29 over 18's got to be in here somewhere. Really is a lot easier to look at those and say, oh, that fraction is less than 1. It's bigger than 1, but less than 2. It lets you sort of ballpark in where these angles are when you're thinking about them. Whereas we know where 290 degrees is because we're really familiar with the circle. Well, 0, 90, 180, 270, 360. Oh, 290's got to be here. We can all pretty much do that without thinking too much about it. But it's a lot harder with radians because we're not used to them yet. Where's 2.97 radians? Well, that's about 3. Okay, we could then compare that to 2 pi, which is a little over 6. But it's a lot easier to look at 17/18 and say, oh, look, a little less than 1. All right? Guys, this is going to be the standard. When I ask you to convert from degrees to radians, I want a simplified fraction with pi. I want the exact value. All right, 5 pi over 12 radians converting to degrees. Ben, you're up.
All right, top left I said 5 pi radians. Top right 360 degrees. 2 pi radians in the bottom right. And then
I feel like we're missing a 12.
Oh. I do not have a phone.
Uh-oh. Where do you think the 12 might go in your, because we got 5 pi over 12 here.
Oh, shoot. Pardon me. Darn it, I didn't know.
Guys, when you're putting a fraction into a bridge, just stick the top half of the fraction in the top of the bridge and the bottom half of the fraction in the bottom of the bridge. And that way you don't have to really think about it. Because that's the same thing, right?
Wait, say that again?
When you're putting a fraction into the bridge, just put the denominator down here. Because that is 5 pi over 12. Ben could have written his bridge like this. 5 pi over 12. But now now what do I do with that? It's actually more complicated to think about it that way, as opposed to, hey, look, there's 5 pi over 12. So now what? Ben, can I simplify before I just start piling things into my calculator?
12 and 360.
12 and 360. Good. That would be 30. What else?
2. 30.
2 and 30. There's 15. What else?
I got it. Oh, well, radians too. Is that what you mean?
Yeah, radians. What else?
That's all I got.
Anybody see anything else that simplifies? Jesus. Oh yeah, remember when I said at some point we'd be working with radians and the pi's would just nicely cancel out? If I'd written 6.28 there, well, then I got to type into my calculator, and I've just made it inaccurate because I got pi over 6.28, which isn't really exactly 1, but the pi's cancel out. So let's dig through this mess and see what I'm left with. 5 times 15 divided by 1. Didn't actually even need a calculator for that one because the only actual calculation I did was 5 times 15. And since we all know our 15 times tables, yeah. Even if we don't know our 15 times tables, right? 5 times 10, 5 times 5, boom, 75. You good with this? Here's a conversion factor to add to your toolkits. In fact, your toolkits may have a section on radians, maybe. I don't know, flip through and look. See if you can find something that says something about radians. Or maybe you write it on your unit circle. Maybe that's easier. Conversion. Guys, this is a unit conversion. This is a good one to know. 2 pi radians equals 360 degrees. Yes, that would simplify. You could theoretically simplify it to pi radians equals 180 degrees. It doesn't really matter. The nice thing about 2 pi and 360 is that even though it's a little less simple, you're thinking about a whole circle instead of a half a circle. Oh, there's like a whole nother unit circle in your toolkits. That was stupid of me. I didn't even realize that.
It's smaller.
It is smaller. Yeah, I don't like it as much. I'll probably take it out next year. Maybe I'll put the big one in next year and get rid of that one.
Yeah.
Yeah?
Yeah.
No, keep it.
Yeah.
Why?
All right.
I'm gonna say,
You ready?
No,
Yeah, you are.
I can't even find
Wait,
the circle. I don't think I have one.
yeah, it's in here. It's number 9.
Oh,
Perfect.
Number 9.
Number 9.
Number 9. Number 9.
should I have done this?
If we weren't streaming on YouTube, I'd totally play that song.
What song?
Revolution number 9.
Oh, yeah.
That's how it starts. Number 9. Number 9. Then I'd get another hit.
Did you already write on
And that would be 3. And then they might start to say, yeah, I don't know about this guy.
You got copy strikes?
What?
You got copyright strikes?
Well, what happens is I forget to turn this off, and then I go sit at my desk and play music while I work. And then it hears me playing music, and then if it's something popular like the Beatles, I get a copyright strike just for sitting at my desk playing music. It's like, oh, come on. Meanwhile, you can go onto YouTube and you can find music from any artist you want by like 800 different people who've all just stuck it on a thing and posted it up.
Well, I'm pretty sure they put the credit in the description for the music.
You got a credit thing, Coach.
So you mean if I just, all I had to do to be able to play my music is go back and type in music by the Beatles while I work on math homework? I don't know. I don't care. I just turn it off before I play music. All right, here's what we're doing now. Angles in degrees. Angles in radians. 0, 30, 45, 60, 90, 120, 360. I'll get you started by doing the first one for you. 0.
Thank you.
You're welcome.
Very kind of you.
Exact values, not approximates. Exact values, not approximates. Go. Yes. I don't know. Can you?
Man.
You may. I hope you can. Otherwise, you know.
Is there a sign up sheet?
No, just go. You might also consider, after you've done the first few, starting to look for patterns to make your life easier. Because that's what patterns do. don't forget, it's perfectly acceptable to talk to your partner and discuss strategies and look at your answers. I have a partner.
Hey, man.
Yeah.
You can do this exact. That's the exact stuff. Yeah. No, that's right.
Yes.
I hate this. I'm doing this thing. Mhm. No.
I need to update it.
Yeah, you do.
But you want to hold on. Okay.
So just this is multiply, divide, and then what do you do?
You keep it, you don't simplify it, but you want it to be fixed.
Oh, so you got pi over it.
Yeah. Mhm.
So for the first one, it would be 30 times 2, right? Oh no, you simplify these two.
Mhm.
Oh, okay.
Yeah.
So then you
What's Circumference?
I'm stupid. Wait, it's,
Okay.
360 divided by 45, right?
I'm not interested.
What else?
Yeah.
And then you get 2, right?
Also, I think this is wrong too.
Okay.
I'm doing wrong.
Which one?
Um,
How many times is 3 going to 36?
yeah, this one's wrong. It's not good. It's just- Wait, yeah, writing. Subdividing.
Do, oh, I did it right. You get, oh yeah, you probably did it. You feel like you have something. Wait.
Divided by 120 is 3.
And you have the 2 on top of.
Yeah.
So it'd be like 1.5. No. What would you get? Oh, you just put 2 pi over 3.
Yeah, do that, right?
So, I don't see why that would be wrong.
Is that like accurate or what?
It's,
Exactly.
it's exact. I think, I could be wrong, but I think. Do you know what typing?
That's,
Where are you doing?
what if this happens?
Well, then you can do, you have to do it by 15. You can't just do 360 divided by that. You have to find a common number.
Yeah, so 3, and then, well, no. Because we divide that, so that is 3.
Oh.
Divide this one by 8. Then divide 3. And go to the top. Cross out 8. 3, 5.
So do you like the?
Yeah.
Like, there is a pattern, but that's not easy to figure out. Well, it's like one way, like, it's not something.
Is that for them?
Every day after school, that's the first thing I do. I have school.
It goes down enough. There's not much of a pattern.
I'm a nice.
I take up more.
Finish the rest of this? Not before you do it.
That's my safe. It's like, she's done.
Do you pick up on the toilet?
How come there's so many pies? Am I missing something? Pi over 3? Pi over 2? Pi over 4? Pi over 6? I don't know what that means.
Is that you? Oh, that's,
Because that would be pi squared, right? I know what you did. What did you do?
Well, I saw that like 180 was pi.
Yeah.
So I was doing like
Plus. You didn't write pi.
Oh,
plus.
oh.
You wrote pi,
pi.
pi over times pi over 6. Now, can you simplify pi plus pi over 6 into a, what they like to call it improper fraction? How many pi over 6s is 5?
135.
How many pi over 6s is 1 pi? How many pi over 6s in 1 pi? What does over 6 mean? 6. So this is 6 pi over 6, and that's 1 pi over 6. How many pi over 6s do you have? Boom. There's your answer.
oh, yeah, you're right, because it would be like more.
Yep.
Yeah.
Yep.
Hate it. 1 1/4.
That's what I thought.
They have their uses, 1½ cups of flour. Can you write this all as fractions? Cool. And just out of curiosity,
This works.
Yeah.
You know,
Mm.
I gotta hear you.
I got both my coping mechanism and stage my legs.
I do the same thing.
Don't you dare.
And I write 2
I
feet
have
one.
one.
So crazy.
I said it's so funny.
She's gonna make me spell. That's pretty good. I'll go like this.
Yep. I think I did it wrong though, so.
I don't see a pattern.
I see a pattern, yeah.
Oh, no, maybe I didn't. What'd you get for?
120. 2 pi over 3.
What?
What did you get?
17 pi over 18.
Wait, what did you get it for?
One one.
120? Oh, no, yeah, yeah. I didn't.
You got 17 pi?
I could write like that.
How do you get
I got 17.5.
I like it.
Wait, can you explain?
What? This could be wrong. This could be very wrong.
Good place to start. You and Carson should chat sometime.
Me and Carson should chat?
Carson and I.
Oh.
You don't? Look at the ones,
Did I do it right?
look at the denominators.
Did I get it wrong?
Probably.
Okay, fair enough, yeah.
Did I not do it right?
Maris, I don't think you did because 17 over 18 would be 170
That's what I'm wondering.
All right, here we go. 30 degrees.
I don't know.
Maris.
Pi over 6.
Agreed?
Yes.
All right. 45 degrees, Jetsy.
Pi over 4.
60 degrees. Gone. Macia.
Pi over 3.
Hey, I got a question for you. How many 30s in 60? So do we agree that 60 should just be 2 30s?
What?
Yeah, I'll make that one.
What do you mean it makes no
so
sense?
you
60
divide by
is
3,
30
yeah.
times 2. What do you
Yeah.
mean makes no sense?
Yeah.
Yeah.
Okay, yeah, that makes sense now.
Okay, so let's start with, I'll think about it for a second before shouting out at somebody, you make no sense! Guys, are we in agreement?
Yeah.
Hey, look, there's your first pattern.
You could do the same for 90.
90? How many 30s?
Oh, I was, yeah.
So you mean that's 3 pi over 6?
Is it?
Which simplifies to what?
Pi over 2.
Oh, look at that.
Can you do 225?
Do 120. Do 120.
No,
Because I
do
think I'm wrong.
225. No,
I'm definitely
do
wrong, but I
225.
was so no.
Anybody see the quick way to get to 120?
4 pi over 6.
Could be 4 pi over 6, but I sort of like the fact that this just double 60. Then I don't have to simplify anything. Hey, look, it's 2 pi over 3.
Oh, what a dog.
Can you do? No, I was
I
gonna
did
get
it.
can you do 225?
No,
What? Why not?
I know.
cuz.
But 225 is
Stop being needy. We're going to do the whole thing, so stop saying, please do this one, please do this one, please do this one. Because it's annoying. It's annoying. Shush. Shush.
Megan, what'd you get for 330?
That's
That's what I thought.
okay. Okay. I thought it was good.
All right, here we go. Thomas, 135. Where else had we seen a pi over 4? Oh, how many 45s in 135?
I guess 3.
You guessed 3? Totally is, yeah. Hey, here's the interesting thing to me. Having done this as long as I've been doing it, when the number 135 pops up in something, I immediately would think to myself, oh, wait, that's 3 45s, because going around the circle, there's a 45, and then there's another 45, and then there's another.
Good afternoon, everyone. Reminder, or at least telling you, maybe for the first time, to wear your Meridian Strong shirts to school tomorrow. Students, staff, everybody
No.
Really strong choice.
You have one or something?
No. They tried to give me one and I said, no, thank you.
What are they for?
They're for wearing.
I'll wear mine.
I would wear mine, but I have to wear my uniform.
All right, guys. Hey. Time out. We're running out of time here. Let's roll. Come on. 150. Ryben.
5 pi over 6.
Oh, look at that. 530s. 180. No, I'll just do that one because that's too easy. I know you were bummed out, weren't you? Nate,
Yeah.
210.
210. 7 pi over 6.
Oh, look, 7 times 30 is 21. 210. Megan, 225.
5 pi over 4.
Oh, you mean that's 5 times 45 is 225? What?
I got like 15 pi.
Mark, you were wrong then. What?
I got like 50 because
15 pi over 12.
what?
15 divided by 3 is 5, and then 12 divided by 3 is 4.
Oh, there you go. Mark, 240.
4 pi over 3.
Hey, notice 6 times 4.
Whoa.
Here's the thing. All of these are part of the pattern. And because they're part of the pattern, once again, once you know the first quadrant, you can easily figure out the rest because they're all multiples. Akil, 270. Oh, look, 390s. Macia, 300. Yeah, 560s is 300. Couple more. Don't pack up quite yet. Carson, 315. Come on, Carson. Don't figure it out
I
now.
think what's divisible by.
You should have written it down on your paper.
Gotta be 45. How
Well, I
many?
didn't get that far.
How many?
45, so it would be like 7 pi over 4.
Boom.
Let's go.
All right, last two. 330, 11 pi over 6, and 360 is 2 pi. All right, guys, we'll continue this tomorrow.
Please come to the office. Tyler Mark, Olivia Grillo, and Dustin Dykstra. Tyler Mark.
Good. Nobody in my class is in trouble. Jesus.